specialist for Middle East and Africa, and we hand over to you.
All right, thank you so much, guys. Before we go any further, because now we're going to dive deeper into Infoworks WS Pro, IW Live Pro, its digital twin for the water distribution, supply, and irrigation. Is there any question? I know Misbahu has covered, the complete water cycle that Innovice provides, from drainage, storm management, stormwater management, sewer management, flood, rivers, operational analytics. Is there any question when it comes to these these packages before we go dive deeper into the solutions?
Okay. Are there any questions? Any questions on the floor? No questions, Hassanin.
No questions. All right, cool. All right, so let me share my screen.
Share your screen. Yeah, he's about to start. Okay.
All right. Does everybody see my screen?
Oh, the audio has gone back to my headset. So just change it. Yeah, we can see your screen.
Yeah, excellent. Excellent. So in this presentation, we're going to dive deeper into the water distribution, the water supply, the irrigation side of things, the pressurized networks. As Misbahu said, we have two offerings. We have InfoWater Pro and Infoworks WS Pro. Now, we're going to focus more on Infoworks WS Pro. Before I go further, I would like just to highlight a couple of differences between these solutions. On my left is InfoWater Pro. On left-hand side, this is a solution that works inside ArcGIS Pro. So it's a solution that works inside this ArcGIS Pro environment, and it needs it as a prerequisite. As a result, you'll be able to see the data from GIS. You'll be able to also use the the results, the dashboards, all the nice tools inside ArcGIS Pro, but it will need it as a prerequisite. On the right hand side, Infoworks WS Pro, which is the product of choice today, it's a standalone solution. So although it can also import from GIS and export to GIS and retrieve intelligently from GIS and other data, it is a standalone solution. It does not require ArcGIS Pro as a prerequisite. On top of that, it has a lot of collaborative tools that we will be looking into, and it has a digital twin. So what I mean by digital twin, it's a tool that works on top of Infoworks WS Pro that automates the simulations at a predefined frequency, and that will give you warnings. Okay, so these are the differences between the two tools. Of course, Infoworks WS Pro has a more sophisticated proprietary engine, which is an engine that we have made for almost 40 years, whereas InfoWater Pro works on the free EPANet engine, right? This, of course, gives you some differences as well in the results, which I will highlight also, touch on today. So Infoworks WS Pro, right? What does it do? So it's a solution that will carry out the design and the analysis of existing and future water supply systems, right? So it could be a bulk water supply, but it's a pressurized network. It could be an irrigation, after the treatment plant treating the water, you irrigate the water to the, for agricultural reasons, for example, or for any other reasons. So it could be all of these reasons, or it could be all of these reasons. What Infoworks is WS Pro is very good at. It's really good at risk and resilience assessment. So it really gives you defensible scenarios why you are using certain network, in what way you're using it on the design, but also on the operation. So at certain point, if you have an IW Live Pro with you, which I will show a couple of if you have the package, the offline model Infoworks WS Pro and the online model IW Live Pro, then you get to the point where you are able to even optimize your energy, your pumps, how you run your system. So there are many things that Infoworks WS Pro can do, beside water quality, beside beside doing like fire flow analysis, as Misbaha mentioned, turbidity, age of water, transient, surge analysis. It's all in one package. So it's not a solution where you will buy different packages for different reasons. So it's completely unlimited. There is no limitation of how big your network is. I will give an example of one big smart city scale network that we did in Infoworks WS Pro very efficiently. And it's a solution also that is very good at connecting with the big data. It's very good at connecting with and integrating with the SCADA, telemetry, the sensors, I don't know, weather forecast, demand. We can connect with different data sources out there. And what I mean by connecting to them, so you don't need to even download them. So we connect to the files or connect to the database, and it is source agnostic. So this supplier with this I don't know, with this type of sensor, we don't care what supplier it is. We're always going to connect with the database itself. Okay, as well as we have very nice customer service level reporting where you have some nice and basically results and some nice functions to report to either the client being a government or a private client. Okay, I have a model actually that I wanted to show, but I think I will come back to it, like a quick demo about a quick functionality, about replicating a pipe burst here on my right-hand side. I won't play it fully today because I don't think we'll have the time, but I'm happy to come back to it or organize some other sessions about it. Okay. So I'm going to go through the main functionalities in the software. Okay, that will give you an idea of how the software work. Okay, and what are these main differentiators as compared to the rest of the software. So first, we have very extensive GIS connectivity. Here, you can really exchange data with GIS. And on the video here, what I'm showing is basically, how you're importing the GIS. And when you import the GIS, you have the ability to even choose to add to the GIS, to replicate the GIS, to rewrite, to delete, and add. So we have all the ability, to do that. Now you have also the ability to look at web WMS, and as well as Google Maps, Google Street View, etc. So you have the ability to import from these resources and use them to map your your network. Now, if you do not have GIS, that's not the end of the world because you can also import from CAD, for example. One of the things Misbah showed in his last slide was how we look at the complete project lifecycle, project management. And today we already have some integration between CAD, Civil 3D, and info drainage. So they are completely integrated and they exchange intelligently the BIM workflows, and the data. Now, with Infoworks WS Pro today, we have it as one way rather than two-way, but you can still import from CAD, CSV, and different other, of course, other elements. You can also, this is maybe a bit advanced than what I'm showing here, because what you can do is you can also actually write a script. So you can automate certain things. You can automate the ability to import from GIS. You can automate certain processes. You have scripting also involved in Infoworks WS Pro. Gentlemen, what I'm trying to show you today is just a couple of things about the software, but the software really does not have a limit. It can go very far, as far as the details and as far as the sophisticated analysis. But just to give you an idea that you can also do some scripting, you can also do some automation, in the workflows inside Infoworks WS Pro. And of course, this can also you can also do some auto updates for the hydraulic model. Okay. When it comes to telemetry, we have the ability to directly connect to many types of telemetry. Like, I don't know, SQL servers, oracles, ClearSCADA, PI. We have also a tool called Info360, which is a dashboarding tool that Ms. Baha mentioned. It's a business analytics tool. It's a dashboarding tool that can also make some dashboards for you besides what you have as results from Infoworks WS Pro, from any other desktop solutions that we have. Of course, once you connect to telemetry data, you can update the boundary conditions, and this will allow you some sort of comparison between the actual, and the predicted values. Now, on my left-hand side, just now, it's showing some actual data in the green, and some predicted data on the blue. So what you will be doing is you can look at this prediction. You start to look at what is happening. You're comparing to what's happening actually and what is predicted, and then you can make some sort of scenario management, and you can start becoming proactive, looking at the problem before the problem really happens, which this part especially we will look at it more in IWE Live Pro. Okay, so you can also leverage the data connection to do your calibration better, you know. So when Misbahu, one of the things Misbahu mentioned is that, you know, some of these tools might be a bit advanced, maybe for the region, but the reality is, you know, you can start from anywhere. You know, I have some customers in Africa, they barely have any sensors, you know, so they need to calibrate their system. Of course, the calibration process will become much more difficult if you don't have any data, right? But you can always do it. You can always, you know, get some, I don't know, if you're looking at water quality, get some lab, you know, analysis on the water quality and calibrate your model to suit that starting point, to suit that boundary condition. And then the product will do its mathematical modeling out there and will be able to track what's happening in your, for instance, when you speak about water quality in your, in your, you know, in your pipes, in your systems as you go further from the source. So really having the SCADA and having SCADA telemetry, having sensors and having, it's more of a nice thing to have, but it's not really a requirement to have, you know. So I really want to double down on this, on this point, is that yes, you can start, you can, you know, we can come to us, we can take your hand from the start of your model, your offline model, until the end of having a really digital twin where, you know, it predicts what's happening in your network and you are able to proactively fix that issue before it happening. So I just wanted to make sure that this you know, this point hits home. One of one of the things, you know, that I get a lot working in the water industry is that you know, no one knows what BIM in water is, right? So everybody will come to you, will tell you, oh, you know, I want BIM, you know, but really it's you know, no one knows what BIM in water really is. Now, I think in Innovize today, as Innovize products, Infoworks WS Pro, Infoworks ICM, the Infoworks products, today we have the ability to basically provide that BIM in water, you know. And what I mean by that is we have the ability today in our solutions that you have one master copy for everybody to access, right? So say you have 5, 6 engineers and everybody with the tool will be able to access that master copy. Everybody will be able to work on one, you know, on one, you know, on one model. Say there's a part of model where there is a supply, a part of the model where there's distribution. There are certain areas, it's a huge model or it's a big enough model that a few engineers are involved in. Then the good thing is the good thing about Infoworks WS Pro and our solutions in general is that everybody will be able to access that master copy. Everybody will be able to track what everybody is doing. So different stakeholders can be involved in there. You can go back in time. You can do some undo, redo. There is some even conflict resolution tools inside that, you know, inside Infoworks WS Pro, which comes in for free. So really, what you end up having is one version of truth. You reduce the time on projects, especially I know for, you know, consultants and you know, and utilities alike. They'll have the ability to employ different engineers on the project and finish that project really faster and have this collaboration. You'll be even able to track, you know, what each engineer has done. So in a controlled manner, and you know that of course that incentivizes everybody to work on the model, and that also helps the engineers to be involved in together in one model collaboratively. Okay, so that's one of the things that I wanted to highlight. Another thing I really wanted to highlight is how you can have very fast results with Infoworks the WS Pro, you know. And the reason we have fast results is, you know, literally because of our simulation engines, you know, of our proprietary engine. Our mathematical engine is very strong, very fast. It's, you know, you can even research it online. It's benchmarked as one of, if not the fastest out there. Today you can do some parallel simulations as well, i.e. you have, you know, you have several scenarios, as I'm showing now on the right. And, you know, you can ask the software to run all of them together at one time. So the software will not finish one to go to the rest, but the software will pick which ones can be finished first, and you know, and it will run it in parallel, you know. So that's one of the things that you can have. So at the end, you'll see all the scenarios out there rather than just one, and you have to wait for the next. Another thing that we do is really the model simulation is really distributed on remote engines. So you can use remote engines as well. So you can use a high performance computer to run these simulations, and you know, like you have the ability to to put as much computational power as you need in that remote agent. Now I'm not saying that you need to do it. Most of the time you do not. But if you have a huge model that I'm going to show you, like hundreds of thousands of links and pumps and pipes, and on a smart city scale, you know, maybe on a Lagos region, this is where maybe the, you know, the remote engine capability is there, where you can use the GPU, the CPU also together. So as far as the IT and the computational power, it's there, and it's benchmarked as one of the best. There's another point here I want to mention. Also, we have the ability to do cloud simulations, right? So you have the ability to go on the cloud today for free. It's an optional tool that you can use, but you can go on the cloud, do your simulations with no IT infrastructure from your computer as well, and you know, you can even be faster than what I'm showing you here with the remote agents. Okay, and of course there is like the results can be viewed in a central server. So if you have like a remote agent, you'll have the central server where you can view the results. I'm going to go now on functionalities. You know, I can talk about Infoworks WS Pro for the next 5 hours, but I'm gonna make sure I'm just you know, going to make it in time, Peter. So hopefully I still have time to go through these functionalities. Now, one of the main things about, or one of the differentiators that we have today is, you know, is critical link analysis. So this is a tool that automatically will analyze your network, right? So we'll have a network, and you know, you want to test the pressures, you want to test the flows, you want to test the demands, you want to test all of these things. You want to test what are the mains at risk of serving certain population, for instance. You know, what the software will do, it will automatically, you know, it will automate that testing for you for the links, for the pipes. What I mean by link is between two nodes, which is the pipe. So it will automate that critical pipe or critical link analysis for you, and it will come back to you with, you know, with a table. In that table, you know, it will be basically us saying, you know, the software saying, well, these are the regions affected. As you can see here, you know, on the, I'm not showing my laser. So as you can see here, it's, you know, some of the regions are affected, you know, and it will show why these regions are affected. If you show if there's any outage or specific time, duration, it will show all of these things together in one table, really where it will highlight these for you. All right, another very interesting tool that we have is GMR, or generalized multi-run. So this is a tool where you can set up simulation run, you know, many simulation runs based on, I don't know, water quality, based on critical link analysis, based on fire flow. You have all your elements out there, and you want to run, you know, these generalized scenarios. You can set it up, and you can ask the software to run, you know, several scenarios for you, depending on the type. As I said, could be like transient, fire flow, water quality. And then the software will provide the results for you for this, we call general, for this general kind of simulation based on different scenarios that you tell it to do for you. And you know, you'll see the result, then you'll be able to pick that scenario. So it's not, there's no limit. So there's no limit of 1 or 2 scenarios. You have that many scenarios, as many as you want. Okay. In terms of water quality, water quality and water quality is another thing that we really excel at. So it tracks, as I said, the movement, concentration of any substance. In fact, we have the ability to do reactions between 2 or 3 or 4 substances, right? So if you're looking at chlorine and you're looking at another, I don't know, something like a ferrous, you know, a sort of a metal, you all have the ability to know the reaction between them, as well as the reaction with the insides of the pipe, the wall of the pipe. Okay. Sorry, I'm not sure if somebody asking a question or. Hello, should I continue or somebody's asking a question?
No, please carry on.
All right, cool. Yeah, so
there's a question.
All right, yeah, sure.
There's a question online.
Peter, you will need to tell me the question after you hear it.
Hang on.
Okay.
Yeah, Mr. Olatunji, your question. Mr. Olatunji, your question.
Oh, okay. Good afternoon, Engineer Peter. Thank you for the opportunity for us to join by virtual means.
Yeah.
I like this introduction to Infoworks water supply, but here in Kaduna, we have a need how to manage the distribution system. I want to know if there is any functionality in the software that can help us to manage the distribution system, especially when it comes to customer consumption, how to read the customer meters. We have more than 10,000 domestic meters in the network. And for now, we use manual method for reading it, and it's not very convenient. Also, how to link the distribution database, customer database, or house connection database to the billing system. Is there any functionality like that in this software that can meet these our needs for managing the distribution system for water supply?
Yeah, thank you for the question. Very clear. Yeah, so
Yeah.
there is the ability to connect now. It's not made to connect for what each meter, you know. So it's more like you set it up for DMAs, like for district meter area, and in that district
Okay.
meter area, you have the ability to, you know, to I don't know, you have a certain number of population. You can do it,
Okay.
you know, and theoretically you can do it, you know, but it's not what the software is made for. Like putting that meter results out there. It's more like you connect with a district meter area, then you have, of course, you have the billing in there. You can put the billing in there. You can, you know, if you're looking at leakage, for example, you can see what you are losing, for instance, as water based on that billing, based on that meters. You know, you can do it, yes, but normally we do it on, you know, if you're going to do it by house, it's going to take you a lot of time. What I suggest we can do is maybe we can look at your, maybe we run a separate session, us together, and we can look at your model, and maybe we take that model and maybe we make a small model of it and see maybe this is what is the best way to do it via Infoworks WS Pro. But certainly you can do it. It's going to be very laborious to set up every meet, you know, it's going to be a lot of, you're speaking about how big a population you're speaking here. 10,000, you mean 10,000 customer meters. So, you know, yes. I would like to look at it more in detail, maybe separately. Okay.
All right. Okay.
Okay.
Thank you.
No, you're very welcome. You're very welcome. But of course, there are ways to do it in Infoworks WS Pro. And one of the case studies is actually about this actual thing that you mentioned now. Okay.
Okay.
All right.
Thank you. Thank you, Engineer Olatunji. Another question.
Yeah, sure. Sure.
Yes, good afternoon, sir.
Hello, can you hear
me? Yeah.
I have just two questions. And my first question is, you talked about the central data server. And the question I want to ask is, are there any authorization mode for another user? For example, maybe the engineer is working cloud-based, and there is another person that wants to access it. Will there be a need to ask for authorization, or the person can just go and access the project from cloud?
Very clear question. Yeah. So there are two things. So I know I went very quick on it, even though I think I'm taking a lot of time. But there are two things. First, when I spoke about the work group and the remote engines and everything, that's all in desktop. So that maybe is, you know, you guys, I don't know, if it's a government, for instance, the government is in its server, so it's got the admin rights for everything, right? So it's going to be inside the server. It's going to be on the desktop. Now, if you want to go on the cloud, it is optional. And before you do it, there is a certain like agreement and a certain like you don't do it automatically. You have to agree to send some of the results on the cloud and use it right there. Okay, so there are two things. So the cloud, so we won't take the results like this, or we don't take the model like this on our own. You or the engineer who is got the admin right is going to be able to use that optional cloud simulation, for instance, and then he's going to be able to share it in the cloud. However, most of the time, what I'm seeing in my region is that this is not needed. it is done on the desk on-prem. I mean, it's done on-prem, but you can send it on a server. But that server is also something that, you know, whoever is the client responsible for that server is going to have the right for it. Okay.
Okay, thank you very much. Then the second question is that are there any continuity of data insertion or updating of data? What I mean is that, for example, you run an analysis maybe in 2000, and maybe you want to work on it in after 10 years. How are you going to put a new data into it, or after inserting the new data, collecting the data, are there any within the program that will show you the difference between the old data and the new data?
Right. Yeah, I get you. So you're saying you're speaking about GIS or SCADA or both? You're speaking about both, yeah?
Yes.
Yes. So if you're speaking, let's take the example of GIS. If you're speaking about GIS, let's say you have already some data in GIS, but that GIS model was updated. Okay. So when that updates, when you come and import that, and import it to Infoworks WS Pro, the software will ask you. The software will tell you that there are, there are some changes out there, and the software will tell you, do you want to rewrite on them, or do you want to have it separately, or do you want to add on what you currently have? So you're going to be choosing on Infoworks WS Pro what you need to add as extra data. Now, when it comes to SCADA, it's very similar as well. So you have some results today. You have some SCADA, you're connected to SCADA right away, but maybe something changes, something in the SCADA changes. You're going to connect to it, in real time or near real time. And you're going to allow, or you're going to ask the software to do it for you. Like if you want to not do anything, just have the SCADA right there, you are able to do it. But if you want to automate it, I'm speaking about automation, then the software will take that result and use that result as the boundary condition to run the new simulation. You know what I mean? And you're going to be able to put it at a predefined frequency, right? So you tell it every 2 hours, I want you to connect to the SCADA and run that simulation, and you tell it, or every 5 hours or every day. So you have the ability to do it right, like this. Okay.
Yeah. Good
Good afternoon.
Sorry, I couldn't hear you. Is that am I clear or?
Yes,
Yep.
that's fine.
Right. Okay. I know you said we're stopping in 7 minutes, but I still have like a few slides to go through. Do I have the time, Peter?
No problem. You have the time. One more question. My question is short. This is my question. You know, on the pumping line, as the pipeline ages.
Okay, I can barely hear you. Sorry, can you repeat?
Okay.
Can you hear me now?
Yes, a bit better, but there's an echo. You can go ahead. Yes.
I said on the pumping line, as your pipeline ages, the internal roughness coefficient of the pipe increases, which means you need to exert more air. The frictional loss increases by so doing. How does the model handle this?
Peter, can you repeat the question? I really couldn't hear. It cuts.
I said,
yes, now it's better.
Line,
yes, pumping line.
If you have a new pipeline,
yes,
as it ages, the internal roughness of the pipeline,
yes,
increases and requires more. The frictional losses increases because of that increased roughness.
Okay.
And the pressure head needed to force water along the pipeline increases as the pipe ages.
As the pipe, sorry?
As the pipe ages, I think he said.
The pipe ages, yes, correct, yeah, okay. Yeah. What is the question, sorry?
I have to say that, okay. How does the model handle that?
How does the model? You have to put in like some data in there. There's a data where you put, if you have an age for the pipe itself. You mean you have an age for the pipe itself? You can input that data.
That means you have to assume a parameter for the roughness coefficient of the pipe.
Yes, there is a roughness. Yeah, there is a roughness that you can change yourself, or you can take the the standard one. the standard roughness that is there in the code. You can take that, or you can choose it yourself. So it will take that into consideration, the calculation. But here we're speaking about the age of water. So we're speaking about the age of water out there, yeah? So yeah, if you can't change it, yeah, you have the ability to change it, if that's your question.
I think his question,
yeah,
was about as a pipe ages.
Okay.
The losses due to friction, the roughness of the pipe also increase, and the pressure required to drive water through that pipe also increases. So
yes,
how
and the
do
damage
you
also
factor
increase,
that?
yeah.
How do you factor that in the model?
How do I factor that into the model? You have the ability to input that. In fact, you have the ability to input that manually. But the software won't know the age of the pipe. You have to tell it. So if you have the age of the pipe and you have the properties of the roughness, yes, the software will take it into a mathematical model and will start predicting for you. But if you don't have it, then you know the software can be only as good as your input in this situation.
Okay.
But you know, if you have
okay.
yeah.
Hassan, can I jump in? I think I have a good idea of what he's talking about.
Okay, go on, Mishbel.
Yeah. All right, so I think basically what he's asking is how you model, you know, the revised roughness coefficient of the pipe after a certain period of time. The issue is in our environment, you know, we basically lack the data to do calibration of the network. When you do calibration, it gives you an insight of what the roughness friction factor of the pipe has become after so many years of usage. So if you would have data that you can use to do the calibration, you can put that data in the network, in the software, and then it can simulate and then, you know, come up with a range of roughness coefficient that, you know, based on the simulation runs. I think
like you mean inversely. I will have to check. I will have to check. Yeah.
Yes.
Yeah, I get you. Yeah,
Hassan,
like rather than
look
putting
at
the
the
roughness,
article.
Yeah.
Look at the article I just sent you. Probably this could help you. You can show that one.
Yeah, I mean, look, let's look at this. Let's look at this separately, guys. I will check this question. I've not done it this way, but I know what you mean. Like you can look, get the roughness, the opposite, not input the roughness and see. You know, I get what you mean, but I have to check it. So Misbaho, if you can write this question for me, I will look with the rest of the extended team and see what they say about it.
Okay.
Right?
Okay, but I just needed us to confirm that's the question that he was talking about, because I thought,
yes, that
you know,
is
I
the
have
question.
A good understanding
that
of
is his
what he was-
question. Oh, great. Let me go back to my extended teammate and ask them about this particular question. For me, I've not done it this way, so I need to check. Yeah. All right.
Okay.
Now, yeah, I just wanted to highlight like a couple of slides, then we can finish. So for the water quality, which was something we were speaking about, basically, as I said, you can track the water quality throughout the system, and you can see a representation for it. So you can then schedule some network flashing actions. You can schedule some, some adjustments to the network. But you will know the areas affected. You will know the pipes also being affected. One of the things that I mentioned this proprietary engine a lot, and one of the things that I wanted to highlight here is how Infoworks WS Pro can provide some realistic demand modeling. So normally in other software, you will see when you cut off the supply, it will go down to zero, then it will resume almost vertically. However, that's not realistic, and you will have some volume of water remaining, and that could be huge amount of volume of water. So some of the things that our proprietary engine is able to do is it will realistically simulate the gradual loss of supply of water, and then when you pick up the supply, it will pick up also gradually. So then you will have some ability to really optimize your network the correct way, the realistic way. So these are some of the things that we also do. Now moving to in IW Live Pro, right? So which is the last part that I wanted to highlight, and then and then I will stop, Peter. So just 2 minutes, then I will stop, and then we can resume with some of the case studies. Okay. I mentioned Infoworks WS Pro. So Infoworks WS Pro is this collaborative, water distribution, supply irrigation solution that can connect with, I said, GIS, with some controls that you have, some demand. You can plan some growth, risk assessment, water quality, turbidity, etc. So that's your offline model. Say you have your offline model, and you have made your offline model, or you have your existing offline model in another software or in GIS or whatever software that you have. You can calibrate the network, calibrate the model in Infoworks WS Pro. That's step one. Now, step two is then you move to IW Live. And IW Live is this digital twin, right? So what will IW Live do is it will automate the simulation for you at a predefined frequency, as I said, and it will start to give you some prediction, some demand prediction, and some insights into the future. So it will look at the historical data, and will look at the historical analysis, and it will predict what will happen in the future. And it does this in near real time, because it will be able to connect with the SCADA, with the demand forecast, with telemetry, any telemetry updates that you have, any asset status updates you have. So it will be able to connect with all of this. And by doing that, you have the able to take the best action. You have the ability to take, to notify customers if you have any problem, like the question we had earlier. You have the ability to even optimize the controls. So you have the ability to go ahead and optimize, I don't know, the electricity, by running the pumps better. You have the ability to do the critical link analysis and understand that, this link is actually affected, so I might as well change it before you have a problem in the near future. So all of these things, you have the ability to do it. And I'm talking here from the design point, from Infoworks WS Pro. Then you can do the analysis on Infoworks WS Pro, and then you can do the operation and simulation. Yeah. Sorry if thought somebody spoke. Now, what IW Live can do finally is it can serve as an early incident warning and decision support system. So you have, the ability to look. If you look at this, simple graph, you have the ability to look at the hindcast and predict the forecast. So once there is a deviation from what is being predicted in the model, from a pressure side, from whatever report you're trying to get out there, or a demand point of view, then you'll see the deviation. Then the software will send you out a warning to the operator, whoever is the operator, and that could be a warning in an email, that could be a warning in a mobile phone. And the things we'll look at maybe is the demand pressure change, water quality problem, leakage issue. This is where you have certain, 2 DMAs or I don't know, number of DMAs, and you're looking at a particular DMA where you have some SCADA telemetry, for instance, and then, or you have some meters, like some water meters out there, and you can see there is a difference between these. You can see there is, some water being lost either due to leakage or due to other things. So we have built-in tools in the software with the ILA leakage indicators, and we have also this kind of tool where you can look at the nightly flows as well. You can look at at what's happening in real time, and then you can start putting putting your hand on the problem. Blockage burst is another type of issue. And on my right hand side, I just listed some of the things that we have helped our customers with. I won't read them, but yeah, that's mainly some of these problems that we help our customers with on a daily basis. All right, so I'll stop here, then we can resume later with, I was going to show a bit more about IW Live, but I think we don't have the time. We can resume later with the case studies.